This is CPM Calculus Chapter 4, number 136. So we would like to draw a flag that would generate the same volume no matter if it were rotated about the X or Y axis. Okay, so here is our Y and our X axis. Right, we want to basically draw a flag that if it was rotated about the X axis, it would have the same volume as if it was rotated about the Y axis. So for example, this flag right here probably would not do because it's going to create like a spherical shape here, and then around the y-axis is going to be a completely different shape. Okay, so the idea here is you're going to want to make sure you have the same volume. The easiest way to do that is to make sure that it kind of goes across the line y is equal to x, right? If my flag is something like this, right, is like a leaf, I don't know, when it goes around the x-axis, it's going to be the same volume created that is going around the y-axis because it's symmetrical across both axes because it's along the line y is equal to x, right? This line. All right, so that's one example right here. I just drew it. Is there more than one possible shape of flag that meets the requirement? Yes. So here's one shape. Let's draw a few. Right. I could just have, I don't know. I can have a flag like this. Right. As long as it has the same property of its like symmetrical. That's the easiest way to do this. Right. If you rotate this shape around the x-axis, it's going to have the same volume as if you rotate it around the y-axis, right? Because again, there's the symmetry with respect to the line y is equal to x. All right, so let's go ahead and finish the question. Does your flag have any special property that ensures these volumes of rotation? Right, well, I just said it. The property is there is symmetry about the line y is equal to x, right? But does every graph that has the same volume rotated about the x-axis and y-axis need to have this property here? Actually, it doesn't, right? As long as the volumes are equal. So you could actually find a shape that does not have this property that has the same volume though. Let's see, for example, like if you were to create just a rectangle like this, you could find a rectangle that has a volume when you rotate it on the x-axis, right? This is our x-axis. It's going to be a cylinder, right? It's going to have this shape here, and it's going to have some volume. And then when you rotate it about the y-axis, it's going to be a big round cylinder, right? Right, it's going to be something like this. I'm trying to draw three-dimensional. So this is what it would look like about the y-axis, and this is the x-axis, right? You could find a rectangle dimensions that are going to have the same volume, right? This figure and this cylinder, they're both cylinders would have the same volume. So it doesn't necessarily have to be symmetric about the line y is equal to x, but symmetry about the line y is equal to x, like these two, kind of guarantee that the volume will be the same no matter which axis you rotate the flag around. Okay, so that ends CPM Calculus Chapter 4, number 136.